sure you have the ability to do something. And that is in geometry. Can you show or recognize a contradiction? All right. What do I mean by a contradiction here in geometry? Two statements that are geometrically impossible to happen at the same time. All right. Based on what you know from geometry so far this year, there's no way these two statements can happen at the same time. So I have three listed up here. First, about triangle BEF. Two of those can't happen at the same time. Absolutely not. You and your group, I'm going to give you about a minute and a half. Read through each statement and say, all right, whoa. These two on the same triangle, no shot. Not going to happen. All right, it is impossible. They contradict each other. Go ahead, find those two statements. It's all on triangle DEF. Which two cannot happen on triangle DEF at the same time? Yeah, went over it everywhere. We're good? Did you get a fresh haircut? Yeah. Nice, looks good, man. Looks good. Way to go.
It definitely can't be the right angle, right? Because if D is congruent, you can't have two 90-degree angles and then still have a triangle.
It says that
It doesn't say that, but also, yeah, it doesn't. I know, it doesn't have to though, because you can't have D congruent to F, and then be a scaling, and then be a right angle because you can't have be a right because DEF is a right triangle.
yeah.
Yeah, but like isn't scaling isn't the side, none of the sides are equal.
Which two cannot happen at the same time?
Well, isn't it like, remember like the thing where it's like the biggest goes across from the biggest side? So if none of the sides are equal, that means none of the angles are equal. Right? Does that make sense?
All right, let's get back.
Or 1 and 3.
Any group confident? Which two cannot happen on triangle DEF at the same time? What do you guys have? Scalene and D congruent to F. Yeah, hey, take a look. If I take triangle DEF and I make angle D congruent to angle F, what type of triangle is it? Isosceles, can't be scalene. All right, so that can't happen. You can't have two congruent angles in a scalene triangle. All right, so yes, it's those two that contradict each other. I don't know. I've heard a couple groups talk about maybe 2 and 3. If you have DEF as a right triangle, yeah, D and F can be congruent if E is the right angle, because these would be 45 and 45 degrees each. So that could happen. All right, but 1 and 3 could not. So that's what's going to happen today in our proofs is in your statements, you're going to have two statements that cannot happen. They're impossible. They contradict each other geometrically. If at any time tonight or tomorrow you need a review of the steps, I'm not going to read through these at all. These are the steps. So let's just hop right into the fire. What do you think? Let's go right to example 1. Let's pop right in. How do I know I have to do this proof indirectly? A new style. All right, how am I going to know versus all the we've probably done at least 50, 60 proofs, maybe more this year? Probably more, right? How do I know I got to do these a little differently than what I've done those last 50 to 60 proofs this year? Anybody see anything definitely different we had never seen this year? Gabby? There's knots happening up here. All right, you see one in the given, and more importantly to me, you see it in the proof statement. If you are ever asked to prove something is not happening, that automatically signals you need to do an indirect proof. Forget about the givens. I don't care about the givens. If I see it in the proof statement that something is not happening, or I see the symbol not, we're done. It's an indirect proof. All right, so what are the steps? How do I accomplish this indirect proof? Well, you already see, nothing changes yet. Step 1 is our givens. I wrote those in for you. You're welcome. Here's where it's going to start changing. After you put your givens in. Next up, we are going to make an assumption. Oh boy, that's never good. We're going to make an assumption. And that assumption is the opposite of our proof statement is true. So we're trying to prove A congruent, not congruent to C. So we're going to assume A is congruent to C. And watch what happens when we do. Bad stuff is going to happen. Which is actually good for us. And just a reminder, the givens are always true. Those are always true statements, right? So we're always going to assume the opposite of the proof statement is true. And we can use it, mark it on your diagram, A congruent to C. And also, I didn't mention it yet, look back at our givens. AB is congruent to BC. Do you see these two overlapping triangles? And that's why I had the colored pencils out if you needed them. I want your help right now. Can you get these two overlapping triangles congruent? Just trust me. Just trust me on this first one. Can you get those triangles congruent? Well, we're almost there. I have a pair of angles by our assumption, and I have a pair of sides by our givens. Is there anywhere else you guys can go to find that third pair? And just think where we've been. All right? Just think where we've been. I know this is a different style of proof, but still, I'm trying to prove the triangle's congruent. There's 5 methods. I got an angle, I got a side, and do you see anything else? Yeah, go ahead. Angle B. Good job. Yeah. Angle B is the shared angle in both. And just stay with me here. I'm going to wrap this up nice and pretty here in a couple steps. Angle B congruent to angle B, reflexive, right? Hasn't been that long. And that gives us another pair of angles. Anybody got a method? You just got to see, is AB in between them? Is BC in between them or not? Draw them out if you have to see what my method's going to be. Triangle ABE. Triangle ABE. I got to go CBD. Anybody see the method? Out of the 5 there. What's my method here? Ziv. That side is in the middle. Good. Oh, now it's going to get exciting. Now we're going to get excited here. Wait a second. I think last unit I showed you guys that if the triangles are congruent, so are all the corresponding sides and angles, right? CP, CTC. Oh! Wait, you're saying all the corresponding sides are equal? Everyone is agreement there, right? Including side BD is going to be congruent to, what side does it match up with in the other triangle? BD and BE. And that was called, from last unit, CP, CTC, CP, CTC. You are lucky your paper's not catching on fire right now, and my board has not exploded. Do you see what you have written in your statements? Something that can't happen. Look at your statements. Didn't you just say at the beginning that BD wasn't equal to BE? And now you're writing it is. No. That doesn't work. That doesn't work that way. All right, does everyone see? We have a contradiction here. Both cannot happen in the same proof. So let me slow down. How did we come up with this? By assuming what? A was congruent to C, right? That's where, this is what happened when we said the assumption. We know this is false. Yes, we know this is false. So what do we know about our assumption then? It is also false, right? Our assumption has to be false because this statement's false. So if A congruent to C is false, what must be true? A is not congruent to C, the opposite of it. Yes? So all right, let me do this again, because I know it's hard to pick up at first, because it's brand new, it's uncomfortable. We all agree this is false. because you told me this was true up here in the givens. So if that's false, what led us to this? By our assumption, which means that's false. So if A congruent to C is false, what's got to be true? If A congruent to C is false, what's got to be true then? A is not congruent to C. And that's what we wanted. And here's our reason at the end of every indirect proof. Assumption, which is what we made in step 2. Our assumption led to a, what did it lead to? Our assumption led to a contradiction. There we go. Now, whoa, not done yet. What class are we in? It's not a trick question. Honors, yes. I would like you to prove to me that you actually know where this contradiction has happened. So in brackets, right underneath that, please tell me the step number or step numbers that your contradiction occurred in. So BD not equal to BE was in step 1. And where did we contradict that? Step 5 by saying it was. So please tell me the 2 lines that your contradiction occurred.
Do we have to do that on the other proofs?
Other proofs? What do you mean?
Like
anytime you do an indirect proof, I want it there.
the brackets?
Yes. If it's not an indirect proof, there's no need. There is no contradicting, right? All right. What, Matt? Go ahead.
On the midterm and regions to do that.
Midterm, yes. Regions, no. You don't need it there. This is just like a honors type thing I have you guys do only. Okay. All right. Before we get to the next one, because I know you're so hungry to get to the next one, I could tell. Let's just review. How do I know an indirect proof needs to be done? Proof statement has a not in it, whether the symbol not or the word not. How do I start an indirect proof? With your assumption. Where's the assumption come from? Opposite of the proof statement. There's your assumption always, opposite of the proof statement. And then finally, and this is what I really got to get across to you guys today and tomorrow, you need a contradiction. What are you probably going to contradict? One of the givens. Okay, I'm going to tell you that right now. One of the givens is what you're going to contradict. And what given are you probably going to contradict? The not one, because it's easier to say it is equal. All right, so that's probably what we're going to do. Questions that you guys have before we do one more together? Oh, you're hungry. Let's keep going. Come on, keep feeding you. All right, stop. Everyone stop. How do I know this proof's going to be done indirectly, other than it's indirect proof day? Sania, go ahead. What's in the proofs? Not in the givens. I don't care what's in the givens. It's the fact that this is in the proof statement. That tells me, boom, that's going to be done indirectly. Givens are already written. So now I'm going to start with my assumption. And by the way, if you have a clean, I didn't write it in for you, you can put the assumption first and the given second. The order doesn't matter. Okay, order doesn't matter what comes first and second. So what's going to be my assumption here? What am I going to assume is true about this diagram? Go to your proof statement. Go to your proof statement. What are you going to assume is true here? One zip. Matt, here we go. Now you can speak up here.
BD bisects AC.
That's what we're going to assume is true, that BD does bisect AC. What do we want to contradict now? Again, I'm not doing anything. I just want to make a plan with you guys before I start writing away. Look at, you have two givens right now. ABC is not isosceles, and BD is an altitude. I want you to contradict one of those eventually in your proof. Which one do you think it's going to be easier to contradict without a doubt? ABC is not isosceles. How do you contradict it? By showing me the darn thing is isosceles. So somewhere, I don't know what step it is. But sooner or later, you're going to tell me triangle ABC is isosceles. And then we have a contradiction and we're done. All right, so here we go. Get me to say triangle ABC is isosceles somehow. So get me two sides or two angles congruent. Doesn't have to be right now. It's probably going to be eventually. Ooh, altitude. Threw that word back at you. Also, make sure you use your assumption in there. What's the first true fact you want to tell me about your diagram now? Give me a true fact about the diagram. That'll eventually say it's isosceles sooner or later. Aiden, true fact about your diagram.
AD is congruent to DC.
Nice. He's using his assumption. AD congruent to DC. Why, Aiden?
Definition of bisect.
Good man. There you go. Back yourself up. Definition of bisects. What else is true about your diagram? Or what else can you mark on your diagram? Whatever. Ooh, 5. Hi, Haley. She took the easy route for everybody. BD, good job. Good job, Haley. Congruent to BD. Now, I could be wrong. Doubtful, but I could be wrong. Looks like you guys are trying to head to proving the triangle's congruent by what you're having me write down on the board here, because so far you've given me 2 pairs of sides. So it looks like you guys are driving to prove the triangle's congruent, which is a good job, which is where you want to go. So if we're going to do that, I still need a pair of sides or angles still. Where are they going to come from? There's one given we haven't talked about yet. What else is on this diagram? Here we go, Ian.
Angle ADB and angle CDB are right angles.
There we go. There we go. Now, our reason is going to be different than what we've used in the past, and I'll talk. Just let me write that down. Angle BDA and angle, what do I got? BDA, BDC are right angles. Usually we put perpendicular lines form right angles, definition of perpendicular, but there are none here. Instead, how'd you know they were right angles, Ian? You know what an altitude is. Definition of an altitude. So you can start writing that now. And then don't forget, what do I still need to tell you about the right angles? Don't forget, what do I still need to mention about the right angles, Zoe? That they are congruent. And yes, this is going to be your longest proof of the year. Congratulations. And there it is. Think we have enough to say the triangles are congruent? I'll ask somebody for the method. Triangle BDA congruent to triangle BDC. What method do you have here for me? 1, 3. I guess Amir, go ahead. Good job. Side angle side. And remember, we're trying to get the triangle isosceles. Not yet. But now from here, you guys make a choice. You can either say, AB congruent to BC, CPCTC, or you can say angle A congruent to angle C. Either one's going to make it isosceles. So your call. I'll do sides because I'm just feeling the sides right now. AB congruent to BC. CPCTC. Now, we can confidently say that triangle ABC is isosceles. For me, anyway, you might be different if you did the angles, but for me, I have 2 congruent sides. Implies isosceles triangle. If you had the angles, write angles instead. And then yes, 10 steps, because we have our contradiction now, right? We're contradicting one of the givens. You told me it was not isosceles. I just said it was isosceles. That's a no-no. So that must mean our assumption is false, meaning BD does not bisect AC. Our assumption is false. Assumption led to a contradiction. And no, I know some of you, can I abbreviate that all tech? No, you can't. Suck it up and write it out. And then just like we talked, what lines? It's always going to be your given, whether you put that in step 1 or 2. Where did we contradict? That it was not isosceles. Where did we contradict that step? 9. Okay, your last step should never be in those brackets. It should be the given, and then whatever line you contradict it on. Should never be the last step in there. Whew, 10 steps. How's that feel? Feel like you're doing some serious work, huh?
Will it always be the second last step?
Probably, yeah. Yep. Anything else? Going? Okay, I'd like you and your group to do the next one, and then call me over when you think you have it. Okay? I want you to work together, and then I'll be confident that you guys can do it on your own.